Hi guys, I hope you are all well. In today's session, we'll be looking at Learning Unit 3, which is a section called Sampling Distributions. As I had mentioned to you in the previous session, this is a continuation of Learning Unit 2, and we're just going to be building upon the knowledge that you had with the normal distributions, where we looked at the bell-shaped curve. We were required to calculate a Z value and then locate that Z value on table 1 of your appendix, and that would be the probability to which we would either add or subtract add to or subtract from 0.5. And alternatively, you're going to see here we further look at two other rules that can be applied with your sampling distributions apart from the 0.5 plus or 0.5 minus rule. So it's not much new information that we're going to be looking at. As I said, we had previously looked at where we would draw up your bell-shaped curve. We would plot down the population value, for instance, if we were working with a mean. We'd plot down the population value down the center. We would then plot, for instance, let's suppose the sample value was somewhere on the right-hand side. Less than this value, we would use the 0.5 minus rule, or if they said greater than this value, we would use the 0.5 minus rule. Alternatively, we'd use, if they said less than, the 0.5 plus rule, and then again, we'd calculate our Z value. That would give us a figure. We'd take this to table 1 of the appendix. We'd get a value, which would be the probability, and then we would apply that in terms of either saying 0.5 minus that value we get from the table or 0.5 plus that value. So this is what we had looked at so far, and we're going to follow exactly the same steps in this learning unit, your sampling distributions. It's just that apart from these two rules, the 0.5 plus and minus, we also look at two other rulings that you might come across. And you'll see that, as I said, the steps are exactly the same. Step 1 is to draw up your bell-shaped curve, plot your population and your sample values, and based on the question, determine whether you are moving away from the curve, whether you're moving towards the curve, or the central line. And then also, again here, you'll see that we look at two more rules, which is the addition rule and the subtraction rule, where you're going to find that it's between 2 points. The second step then is to calculate the Z value. The third step is to take that Z value to table 1 of your appendix and locate the value there. And then step 4 is to use the value you got from the table and either apply the 0.5 plus rule, the 0.5 minus rule, the addition rule, or the subtraction rule. Okay, so let's have a look at the questions here. So we're going to be starting off with exactly as we had in Learning Unit 2, looking at the mean calculations first. So when we're working with a sample distribution of the sample mean, and then we'll also look at a sampling distribution of a sample proportion. So these two examples and these two examples are split between those. So here it says to you that according to Nielsen's survey, radio reaches 78% of children each week. And again, I said to you previously that when we're working with mean values and proportion values, what helps us to identify whether we're working with a mean or proportion is for a mean, they'll give you an average figure. Or they'll say to you that this is the mean number of dot, dot, dot. For a proportion, you're looking for either a percentage or you're looking for them saying so many out of so many. So they would say, for instance, 8 out of 10 times or 8 out of 50 people, dot, dot, dot. So this is what helps you to identify whether we're working with a mean or a proportion. So here, sorry, I forgot to add on here that this is proportions as well. So the first question then says, according to a Nielsen survey, radio reaches 78% of children each week. So here they've given you the general figure. So this is your population figure. And since it's a percentage, that says to us that we're working with proportions. And that this is the population proportion, which is denoted by the symbol pi. How we identify that it's the population proportion is that it was a general figure that they gave to you. They said that according to the survey, this is what percentage of children radio reaches each week. They're not specifically saying that they sampled, for example, so many people, and off that sample, this was the result. So they aren't breaking it down for you and narrowing it down to a sample number of values for which this is the percentage. They're saying that in general, according to the survey, this is the percentage of children that radio reaches. So that's your population proportion, which is denoted by the symbol pi. And then they say to you, suppose that we took a random sample of 125 children, so n is equal to 125 from this population, and they computed that the proportion of children in each sample whom radio reaches is 90. So in essence, they're saying that your sample proportion, which is the value of p, is then calculated using the R over N formula, which is 90 out of the 125, since they said that they sampled 125 children and 90 of them said that the radio does reach them. So 90 out of 125 is your value for P, which is your sample portion, and that gives you a decimal of 0.72. So you now have P and you also have pi. And then they said to you, what is the probability that the proportion of children that the radio reaches is more than 72%? So what you're going to do first is plot your bell-shaped curve. Down the center, you're going to, sorry, let me just do that more neatly. So down the center, you're going to put in your population value, which was 78%. That's pi. And as I had said to you in the previous session as well, to please make sure that when you're working with proportions, you convert them to decimals. So this would be 0.78 down the center. Then you're going to plot the sample value, which they said to you was more than 72. So 72% itself, which is 0.72, is your decimal, which is going to fall somewhere on the left. And they said more than 72, which means you're going further to the right. So in essence here, you're moving towards the central line. And whenever you're moving towards the central line, the rule is 0.5 plus. So in this case, once we calculate the Z value in the next step, and then we locate that value on the t-table, whatever answer we get from the t-table, we're going to say 0.5 plus that value. So let's work out what that value is. So step 2 then is to calculate the Z value. And the Z value is calculated for a proportion, remember, as P minus pi over the root of pi multiplied by 1 minus pi over n. So in this case, we can calculated that P was 90 over 125, which is the 72%. So 0.72 minus pi is 0.78, and then it's over the root of 0.78 multiplied by 1 minus 0.78, And then this is over n, which we said was your sample size of 125. So that gives us a Z value of negative 1.62, and you will leave these as 2 decimal places simply because your table also would have only up until 2 decimal places. So here 1.62 and negative 1.62 is your answer. You're then going to take this to your Z table. Remember, when it's a negative value, you ignore the negative sign and you just work with the value itself. So I'm just going to pull up the table for you. Okay, so sorry about that. I had a technical issue that just took me off. So as I was saying, we are looking for a Z value of minus 1.62. Ignore the minus sign from this point onwards. We're looking for the first 2 digits going down this table. So 1.6, which is here. And then remember I said to you that 0.0 will always be the first 2 digits of the numbers going across. The last number will be the same as the last digit of your Z value, which is the number 2. So you'd go to 0.02. So in line with 0.02 and in line with 1.6, your p-value, which is your probability, is 0.4474. Okay, so we can take this then to our question. So P is 0.4474, which you would then remember we had said that the rule was 0.5 plus. So just to rewrite that for you, 0.78 was at the center, 0.72, and they said more than. So the rule was 0.5 plus. We calculated Z, it was 0.72 minus 0.78 over the root of 0.78 multiplied by 1 minus 0.78 over 125. This gave us minus 1.62. We went to the table 1 of your appendix and we had determined that P was 0.4474. According to the rule, we'll be adding that to 0.5. So your final answer then would say 0.5 plus the 0.4474 is then 0.9474, which is 94.74%. And you would then say that, again, if you're interpreting that the probability that the proportion of children that radio reaches is reaches is more than 72% is 94.74%. So basically there's a 94.74% probability that the proportion of children that the radio reaches is more than 72% of kids. Okay, so that's question 1, and this was the 0.5 plus rule. Then question 2 is saying to you that suppose 20% of students at each school have experienced extreme levels of stress during the past month. So they've said to you 20% of students at the school. So again, they've given you a general figure for this, which means that 20% is the value of pi. So immediately you can do part 1, and I'm just going to clear the screen. So part 1 here is plotting the 0.2, which is your value of pi. Then they say to you that a high school newspaper doesn't know this figure, but they're curious as to what it is. So they decide to take a sample of 160 students. So n is equal to 160. And they ask them if they have experienced extreme levels of stress during the past month. Subsequently, 28 of them replied yes. So your p-value, in other words, is then calculated as r over n, which in this case is 28 out of the 160 students. This gives you a p-value of 0.175, and you can leave it as these 3 decimals simply because there are only 3 decimal places for this answer. And so it's not really difficult to work with it as is, but if you do prefer to round it off to 0.18, that's also perfectly fine. So 0.17 is what I'll be working with here. Sorry, 0.175 is what I'll be working with. And then they said to you, what is the probability of less than 17.5%, which is the 0.175. So less than 17.5% of the students replying yes to the question. So here you would then have 0.175 plotted, which would be somewhere on the left. Then they said less than, so it would be further here. And so this would be a 0.5 minus rule because you're moving away from the central line or away from the curve. So 0.5 minus is the rule that we'll be following. Remember, we want to know what do we subtract from 0.5. So we calculate Z first, which is P 0.175 minus pi, which is 0.2, over the root of pi multiplied by 1 minus pi over n, which is 160. And that gives us a Z value of minus 0.79. So you're going to take minus 0.79 to table 1 of the appendix, locate that value, and then we'll say 0.5 minus that value. So I'm going to skip to the table. We're looking for minus 0.79, but of course we're ignoring the negative sign now. So here you're going to have, all right, it is minus 0.79, but we're ignoring the minus, so we're looking for 0.7 going down, which is here. And then the first 2 digits going across would be 0.0, and then 9 is the last digit, so it's the last column at the top. So 0.7 in line with that. And in line with the 0.9 is 0.2852. So the probability is 0.2852, and now we'll say that 0.5 minus this figure will be your final answer. So let's go back to the question. Okay, so here you had the p-value from the table was 0.2852, and according to the diagram, we had said that we would minus, since we were moving away, so 0.5 minus. So you'd say therefore 0.5 minus the 0.2852, which is then 0.21 20.48, which as a percentage is 20.48%. So when you interpret, you'd say, therefore, there is a 21.48% probability of less than 17.5% of the students replying yes to the question. So you'll literally just take your answer and plug it into the question and convert it such that it will be a closing statement. Okay, I'll give you a second before I skip to the next question. Okay, so question 3 then is where we look at a bit of a new portion of Learning Unit 3 and what compared to what we had looked at in the first 2 questions. What we had looked at in question 1 and 2 is very similar to what we had looked at the end of Learning Unit 2, where we looked at your normal distributions. We applied the same rules of 0.5 minus and 0.5 plus. So here we're going to look at 2 other rules that can be applied apart from the 0.5 rule. And you'll see here that it is either an addition rule that is applied or it's a subtraction rule that is applied. So in this question, you're going to see that instead of them saying more or less than a particular number, they're going to say that they want to know the probability of ... being between 2 figures. So the less than and more than, you don't come across it here, but you do come across them saying that it's between 2 figures. Even if they use the words more than and less than, they would say more than, for instance, 20, but less than 25, which essentially means between 20 and 25. So let's have a look at question 3. And here they say to you, a set of laptop prices are normally distributed with a mean of 750 and a standard deviation of 60 Rand. So immediately again, you can draw up your bell-shaped curve. Here, as you can see, we're working with mean values. So when we calculate the Z value, it is X bar minus mu over the standard deviation over the root of n. So they said to you that the mean is 750, which you can plot down the center. Then they say to you, what is the probability that for a sample of 40 laptops, so n is equal to 40, what is the probability that the average price will lie between 745 and 768? So now when we plot down these sample values, we're going to be plotting down 2 values since they said between 745 and 768. So we'll first plot 745, which would be somewhere before 750, and then we'd plot 768, which would be somewhere after 750. So as you can see, they're saying between these 2 points, which means that the portion that I have indicated using this bracket is what we're referring to. And if you find that when you plot these X values and they lie on either side of the central line, the rule that we'll follow is the addition rule, where you'll see that once we calculate the Z value, and you'll see that we'll be calculating 2 of them, we take both of these values to your to your Z table, table 1 of your appendix, And once we calculate the probabilities, we add them up. So there's no 0.5 rule here. So once we know now that it is two values that are on either side of the central line, this means that we are going to be adding up their probabilities. So let's go ahead to step 2, where we now are calculating two separate Z values. The first time around, when we calculate the Z value using this formula, we use 745 as our X bar. So it will say 745 minus the population mean is 750. So minus 750 over the standard deviation, which they said to you was 60, over the root of n, and n is 40. And then you'll do the exact same calculation, with the exception of you now, in place of X bar, are substituting 768. So 768 minus 750 over 60 over the root of 40, and that is Z value. So as you can see, the only thing that changed was the X bar value, simply because you're now looking at between 2 points and you had to account for different sample means each time. So when you calculate this, you're going to get a value of minus 0.53 on the left, and on the right, you're going to get a value of 1.90. You're then going to take these two values to table 1 of your appendix. So I'm going to pull up the table for you. And we're looking for, remember, Z being minus 0.53, and then Z also being 1.90. So here for the first one, again, remember, ignore the minus sign. So you're looking for 0.53. You're going to locate the 0.5 going down, which is here. And then across, remember, you have 0.0, and the last digit is 3. So you're looking for 0.03, which is here. And in line with that, it is 0.2019. So that's your Z value for the negative 0.53. Then you have 1.90. So you're looking for the 1.9 going down, which is here. And then you're looking for 0. So it is the first value here. So 0.4713. So now you have two separate Z values. And remember, we said that once you have these probabilities, you then are simply going to add them up. So let's go back to the question. So here we had, remember, the first Z value was minus 0.53. From table 1 of the appendix, we got that the probability of it was 0.2019. Then you had for Z, the second time around 1.90, and this was 0.4713. And all you're going to do is add these two probabilities up, because we had said that the rule when we drew up the bell-shaped curve was that since both those values lie on either side of the central line, we would add them up when we got those final probabilities. So you would then say that therefore 0.2019 plus 0.4713 is then going to give you a final answer of 0.6732, which is, as a percentage, 67.32%. So to answer the final question, you'd say that therefore there is a 67.3% probability that for a sample of 40 laptops, the average price will be between 745 and 768 rands. So pretty straightforward. It's just that here we don't apply the 0.5 rule. And when they lie on either side of the central line, we use the addition rule. So I'll give you a second and I'll do the last question. Okay, so let's have a look at the last question then. And this says, suppose the mean number of days to germination of a variety of seeds is 22 days with a standard deviation of 9.5 days. So they've given you here the general figure once again, which is mu in this case, and it's 22. Then they've said to you that they want you to determine the probability that for a sample of 55 seeds, so n is equal to 55, germination will take between 18 and 20 days. So once again, you have two separate values for the sample mean x bar. One time around it will be 18 and one time around it will be 20. So here you're going to draw up your bell-shaped curve down the center, plot the population value, which is 22. Then you're going to plot the sample values, which are 18 and 20. Now, if you look at those values on the bell-shaped curve, both 18 and 20 fall on the left-hand side of this diagram. So when you have a situation like this where both the values either fall on the right-hand side of the central line or they both fall on the left-hand side of the central line, the rule we use here is the subtraction rule. So what we're saying is when you do the whole process of calculating the Z values, going to table 1 of your appendix, calculating the probabilities, when we get those probabilities, we're going to take the larger one and subtract the smaller one from it. So I'll show you that in a second. But the rule again is whenever you have a question where they're still between 2 points, but both points fall on one side of that central line, either both are on the left or both are on the right, the subtraction rule is what we follow. So now we know the rule that we're following. We are able to calculate the Z value. And again, there will be two separate Z values. So the first time around, 18 is your sample mean, less the population mean of 22, over the standard deviation, which is 9.5, over the root of n, which is 55. The same here on the right, but now we have 20 as our sample mean, less the 22 over 9.5 over the root of 55. So this would give us on the left minus 3.12 as our Z value, and then minus 1.56 as our Z value on the right. So we would then, again, as you can see, they are both negative numbers. So we will ignore the negative sign, and in your table, just look for the figures themselves as positive figures. So the first one was minus 3.12. You'll ignore the negative. And the second was minus 1.56. Once again, ignoring the negative. So here you're looking for 3.1 first, going down the table. So 3.1 is here. And then 0.0 is the first two digits. You're looking for 2 then after that. So 0.02. So in line with the 0.02 and the 3.1, your your p-value is 0.49910. Then for the next one, which is 1.5, here is your 1.5, and then your last digit, it's 0.06 is the last digit, so 0.06 is here, and you're going to go once again across the table, and then in line with the 6, which is 0.4406. So that's 0.4406. And now what you're going to do is look at which is the larger of the two and take that and subtract the smaller value. So in this case, the larger is this first one at the top. So it's that minus the smaller one. So let's go back to the question. So here, remember, since this was 22 down the center, 18 and 20 both lie on the left-hand side. The rule was minus. Your Z values were minus 3.12, which gave you 0.49910 as the probability from table 1. This was minus 1.56, which is 0.4406. So you'll say that therefore the larger of the two numbers, which is 0.49910, minus the smaller, which is 0.4406, that would give you a final answer of 0.0585, which as a percentage, if you multiply by 100, is 5.85%. So this would be your final answer, which if you plug into your question and make it into a closing statement, it would say that therefore there is a 5.85% probability that for a sample of 55 seeds, germination will take between 18 to 20 days. Okay, so this is the end of the Learning Unit 3 type of questions that you can potentially be asked. One important note that you would have come across with your lecturer is that in the formula for Z, whether it's for a mean or a proportion, and I just would like to write out the formula here for you, that for mean, the one on the left-hand side, it would say, okay, so this is the mean, and this is the proportion formulas. So the mean says x bar minus mu over the standard deviation over the root of n, and then your proportion says p minus pi over the root of pi multiplied by 1 minus pi over n. This numerator, whether it's a mean or a proportion, so this and this, they are called sampling errors. This is the difference between the sample statistic and the population parameter. Basically saying that it's the difference between the sample value and the population value. The denominator, which is this and this, is referred to as the standard error. Okay, so please make note of those. Those are all of the type of questions that you can be asked for this learning unit. And then the ones that we had gone through today that were slightly new is the addition rule and then the subtraction rule, which, as we said, for the addition rule, they would fall on either side of the central line. That would be the addition rule. And for the subtraction rule, they would either fall both on the right or both on the left. And you would then look at when you calculate the Z value and take off the values from your table 1 of your appendix, whichever is the greater value, you would put that value first. and then take the smaller value and put it second, and you'd work out the difference between the two, which would be your final answer. Okay, so that's it for today. Thank you so much for your time. It is also most of what you'll be required to know for Learning Unit 3. And our next video is where I'll be looking at Learning Unit 4, which is confidence intervals. Thank you guys so much. I will chat to you again soon. Cheers, guys.